Okay, so I think we can now get started. Time is a famba. So let me just start my recording. Okay, so welcome to today's session. So in today's session, the plan is to look at statistical estimations. So I've sent through material in the group. So modularly statistics or quantitative analysis, ragati kure, and at the same time, really a bit complicated as compared to the Mangma modules at part one. So I do hope you are now working on it. So please don't delay to an extent where you end up maybe trying to do everything in a rush, Masar, on the last minute. So please make use of the material that I'm sending in the group so that at least we can have time to revise maybe towards the end. So today, our focus area in the module, I think it's should be chapter 5 or 6 of your module. So I've sent through material for from chapter 1 up to chapter 5. But that material, it doesn't mean kuti, if you have any questions, we'll still go back to it. So the main purpose, first of all, we have to first complete the module, then go to the areas and are a bit difficult. So the first thing, we'll go through all the chapters, then we go back to the areas that might be giving you a challenge so that at least we ensure that the module is finished in time. So statistical estimations, that's our focus area for today. So for statistical estimations, what is it about? It's okay. So statistical estimations, what is it about? So for statistical estimations, you can have that. So statistical estimations, these are usually carried out on samples. So we want to find out certain characteristics about the population. So we want to understand the behavior of the population. Remember, the population is not just people. The population, we are looking at items that we are studying. So if we want to understand certain characteristics of the population, we can make use of samples. We can make use of samples. But what is it about samples? A sample will not give us accurate information, but a sample will give us an estimate. If we are using a sample, I type the actual thing. If we take out of 1,000 people, tikatora isusu 100, totanga kuvabvunza zvavanofarira. 100 vakataura kuti maybe they like our products. It doesn't mean everyone else it doesn't mean all the 1,000 people also like the product. Of course, it can give us a picture. Out of 1,000 people, tikatora 100, kana 80% vakati vanofarira product yedu. At least it can give us a picture of an estimate to say out of the 1,000, so about 800 may like our product. So it doesn't mean that is the actual figure or the actual number of people that will like your product out of the 1,000. But the sample will give us an estimate of the population data. So if we are dealing with a sample, it will give us an estimate. So statistical estimation involves the use of sample to predict the corresponding population parameter. So we are using a sample to deduce the behavior of the population. To understand how the population would behave. But instead of asking everyone, because it can be expensive to ask everyone, it might need a lot of resources to ask everyone. So instead, we can just work with samples because it might not be possible to get the data from the whole population. So reasons for making use of these estimations. Why not ask the whole population? Why do we need to end up using the samples and estimations? So they allow us to come up with a conclusion, even if we don't have all the data. So the statistical estimation, we are saying, even if we cannot be able to access, maybe we cannot ask all the 1,000 people, but we've been able to just collect data from 100 people. So from those 100, we can be able to make conclusions. So because of statistical estimations, we can be able to come up with conclusions that we need for decision making, even if we don't have all the data. Then also, it's not save a time, because instead of conducting a census on every item of the population, we just need that sample. So it can save us in terms of time, in terms of money. Also, besides that, we can also be able to make decisions. Because of samples, we can now make decisions under uncertainty. So we cannot access all the data, but from what we have, from the sample that we have gathered, we can deduce. We have not been able to maybe ask everyone, but from the 100 that we've asked, we have been able to predict that 80% like our products. So if we are now supplying the products, we now supply the products that cater for 800 people out of 1,000. Because we've not been able to ask everyone, but because of sampling, we have been able to come up with a decision. We have been able to come up with a decision. Okay, now let's proceed. Then also, let's talk about the point estimation. Point estimation. So point estimation in statistics is when we use data from a sample to give a single best guess of an unknown population parameter. What are we saying? We can't ask the whole population, but we want to use the sample to come up with the best estimate. So let's go to our Excel and maybe demonstrate that further. So we're talking about the population. Let's go back to the presentation a bit. So the point estimate. So the point estimate, we are saying in a, for example, so that's a point estimate. Can I say something the point estimate? So for point estimate, we are saying in a class, let's say, example, in a class of 100 students. In a class of 100 students, 10 students were asked how much they scored. In the math test. They were asked how much they scored in the math test. And the following results and the following data was obtained. And the following data was obtained. So we have 10 students. Let's call them thus student 1, student 2, student 3, student 4, 5, 6, try to reduce that. So 6, we have 7, 8, 9, then the last one. So instead of asking all the 100, we made use of a sample. The first one scored 30%. The other one scored, the other one can say the second one scored 55%. So this. Okay, so the first one scored 30%, the other one 55%, followed by another one with 36%. Followed by another one with 41%, 45%, 32%, 31%, 60%. 60%, 65%, and 20%. So we have taken a sample of 10 students and we've calculated, we have now their percentage marks. So what is the average mark? Average mark. So the average mark, you can add their marks, divide by 10, because there are 10 students. So you can add So we can add their marks and we divide by 10 because there are 10 students. So we add up, we divide by 10. So we get an average mark of 42. So we then say, so the average on average, or we then say the class average is 42. So the class average is 42. So how did you determine the class average? We've determined the class average. We have determined the class average using only 10 people. At Nagobunza, we've only used 10 people to determine the class average. Now, let's go back to our PDF. So the document was saying, a point estimation in statistics is where we use data from a sample, like the 42% we got it from the sample, as a best guess of an unknown population parameter. We have used the 42% from the sample to say that's the class average. But we have not asked everyone. The class has 100 people, but we've only used 10 people to determine the average. So we have used 42 as the best estimator of everyone in the 100 people class. So that is the point estimation. We are taking one figure from the sample to be a representative of the whole population. We have taken the 42% from the sample to represent the total, the average of the total population. So what are the advantages of using 42 being a representative for all the data? So what is the advantage of using or disadvantage of using 42 as being the estimator of the total population? Number one, there is a lack of accuracy guaranteed. A single number may not be exactly equal to the true population value. We are saying Tawana 42 being the average from 10 people, but it's not always the same if data answer all the data either all the 100 marks and divided by 100. So the average that you got from the 42 students might not be the same from the one that you would have obtained if you had used the whole population. So a single number may not exactly be the case. But if we had given it as a range, maybe to say from 30 to 50, but if we say the average is 42, Tango Shandisa a sample, then it might not be the best estimator. Then it does not show how far the estimate might be from the actual value. So, or we can call that one, it does not show us the degree of confidence. We'll talk about the confidence intervals shortly, but the point estimator does not show us the degree of confidence. Then if the sample is too small, the estimate can be misleading. So from a sample of from 100 people, let's say if it was 1,000 people and we take a sample of just 10 people, if the sample is small, it might not represent the actual thing. Okay, let's move on. So if the sample is too small, it might be affected by sampling error. Then can give false confidence. So if maybe you take a sample of 10 people from a class of 100 and your average class mark is 60%, as a teacher, you might think that your students are doing well. So it might give you a false confidence. It might give you a false confidence, which is not showing the true characteristics of the whole population. So the exam that you write, it is going to be having calculations and a bit of theory. So take note of these advantages and disadvantages. They also ask you to be part of the question. In a maybe Mamaksa Gawanda, you get a section where they're saying find maybe give us two disadvantages of the point estimate. Now, let's move on. Are you done? Okay. Then we have something called the population proportion. We have something called the population proportion in statistics. So the population proportion is the fraction or percentage of individuals in a population that has the characteristics that we need. So the population proportion. So population proportion, we are looking at how many have the desired characteristics. So population looks at how many have the desired characteristics. So the population proportion looks at how many have the desired characteristics. So in a class of 100 people, only 28 can play basketball. Only 28 can play basketball. So our population proportion P would be 28 over 100, which is 28%. So this is easy. It's just expressing the desired characteristics as a percentage. So the population proportion, you're just expressing the desired characteristics as a percentage. So we are saying how many have the desired characteristics over the total? How many have the desired characteristics over the total? That's the population proportion. So the population proportion, how many have the desired characteristics out of the total population? If we are estimating the population proportion, it's still the same. If we are now estimating the population proportion, it means we are not using all the values, we are using a sample. So if we are now estimating, so like from the data we have above here, if we are required to determine the population proportion for those who passed, we can say or let's just copy that data. So the population proportion of those who passed. So what is the population proportion of those who passed? So in this case, we are using a sample. So kana population proportion ke sample, kana P, kana hit pamsoro. If you look at so the population proportion for a sample, P, kana above Sora. So that's the population proportion. So P kaneka bag, it simply means the P we have calculated is from a sample, not from the whole population. So how many have passed? What is the population proportion of those who have passed? What is the sample population proportion of those who passed? So the population proportion for those who passed, that's our P, is going to be, we look at those with above 50%. So if 1, 2, 3, so 3 out of 10. So 3 out of 10, which is interpreted as 30%. So our population proportion is 30% or 0.3. Our population proportion is 30%, or we can use 0.3. Okay, let's move on from there. Let's move on. So besides the population proportion, let's move with our, so after the population proportion, So we have an example here. So in a study to determine the proportion of teachers in Zimbabwe who are degree holders, 800 teachers out of a random sample of 2,000 teachers said they have degree qualification. Find the point estimate of the population of the proportion of all teachers who have degrees. So if they say find the point estimate of the proportion of Zimbabwean teachers who have degrees, that is the P we are looking for. So P, simply how many have degrees from the sample out of the total. So the sample is 2,000 teachers and 800 have degrees. So just 800 over 2,000. Then you express that as a percentage. 800 over, then express that as a percentage. No. Express that as a percentage. Then if there are 15,000 teachers altogether in the country, how many have degrees? So what do you do? First, we are given so that's example from slide. So our P would be, we have 800 with degrees out of 2,000. We express that as a percentage. That's 800 out of 2,000. That's something like 40%. So that's something like 40%. So if we have 40% that have degrees, that's part A. So if the population is all the teachers that we have. If the population is 15,000, it means those with degrees, it becomes, we then say 40%. We use the population proportion we've calculated. So we are saying from the sample is showing that 40% have degrees. So out of 15,000, how many do we think have degrees? We just use that 40% estimate. So it means the 15,000, would say the 15,000 times the 40%, which is 6,000. So it would be 6,000. It would be 6,000. Okay, let's move to let's go to the next, the population mean. So calculating the population mean. So the mean is the average. From the given data, the mean is the average. The mean is the average of the given data. It is calculated using the formula summation of x over n, where summation of x, you have added all the data that we have, divided by n. N is how many values are you given. So n is the sum of the data that you have been given. So we have summation of x over n. Summation of x over n. Okay, let's move. So we have what you call the mean, which is the average. Then we have what you call the variance. So we have the population mean and we have what you call the population variance. So we have the population mean and we have the population variance. So I have the population mean and the population variance. So the mean is the average. What about the variance? The variance should how far is the data from the mean? How is the data distributed? How far is the data from the mean? Let's go to our Excel. If the average is if the average is 42 and the data with someone who has scored 40, with someone who has scored 41, with someone who has scored 43, we have someone who has scored 46. So if you look at these marks, they are close to the mean. So there is a small variation from the mean. If the data we have is closely centered at the mean, then the variance is low. But kana zvikanzi average yedu 42, but vamwe vane 0%, mumwe ane 10%, mumwe ane 80%. The data is very far from the mean. So mamwe values, they're far from the mean. We say the variance is large. So the variance looks at how far is the data from the mean. It's a measure of spread. The variance of the data is a measure of how spread out the data is in a data set from their mean. So if we are having a sample, the variance of a sample is calculated using the formula on the screen. Please take note of that formula. Take down that formula. That's for calculating the sample variance. That's for calculating the sample variance. Did you bring your calculator? No, it has changes now. Lisa? Sample variance. So have you taken down the formula? Okay. So sample variance. Now we want to apply those formulas to this question. So the first question is saying, calculate the population, find the estimate, of the mean. So we want to calculate the sample mean. We are given a sample. Is this a sample or is the population? So the weight of 20 bags of potato randomly selected from a truck of 250 potatoes as follows. So we are given these values. Then calculate the mean weight. Then calculate the variance. So we want to calculate the mean and the variance. So we have the variance and we have the mean. So the estimate of the population mean is this one. Then the estimator of the variance, population variance, is that. So we want to apply that now to this question. But unfortunately, we first of all need to know how to input our data into the calculator. So since you don't have a calculator, maybe let me allow you to use mine. So okay, let's proceed now. So I want you to be following the steps that I'll be going through. The first thing is to feed the data that we are given into the calculator. So you can say calculating the mean, calculating the mean and standard deviation. So the calculator that I'm going to be using is the basic sharp, the dial one. That's the one that I'm used to. Sharp, which is the old, the dial one. So I want to first of all learn how to feed the data in the calculator. So the first step is to feed the data. Is to feed the data into the calculator. So the first step is to feed the data into the calculator. So I want you to go to your calculator, then you press mode, press mode, press mode, more on states. Then you press 1 to states. You press 1, which is states. You press 1, which is states. SD line quad. Kana data ratiri kufeeda, if you look at our data, it's not in the form X and Y. So we use SD mode. If the data is single data, it's SD, single data. So we use the SD mode, which is 0. So you press 0, you put it in SD mode. So it's going to show that it's now in state 0. It means now the calculator is now in statistics mode. So now we are in states mode. Till in states mode, the next thing is to now input the data given on the question. Let's go to our question and input that data. So the data is starting with 10,2. So I want you to press 10,2. Please make sure you're not making a mistake. 10,2. Then you press, there's a button which is M plus. M plus just above my brackets up. So no press at the first set of data 10,2, then you place you press that M plus data to feed the data in the calculator. Yava out today. Do you see panel divided? Then just go up, panel close bracket. The panel button runs M plus in green. You're not saying it. So after pressing that one, what's it would see? Data set 1, right? So you do the same. Unoenda pane the second over ngono by the second value atakapiwa 10,1 or press after M plus. It should write data set 2. General data set 200. So it means so far we have input 2 sets of data. We do the same until the last number. 9,8 over M plus, that's data set 3. 9,9 M plus, that's data set 4. Just make sure you're not making an error because we need to then later use that data we have been feeding in the calculator. So 9,8, then 10,3, and 9,9, then 10,0, sorry. So quickly, I'm waiting for you to finish. Jen? So the last value it was what? 10.7. Okay. So our data set, we have 20 values that we have fed into the calculator. So with that data now, we go to our formula. The mean, how do you get the mean? The population mean, we are saying summation of x over n. So to get the mean, it's summation of x over n. So to get our mean, the sum of x summation of x, you get it from the summation of x over n. The sum of x, you get it from the calculator. And tapedza kuti input our data. I want you to just press on. Just press on in your road states 0. Have you done so? Just press the on button from Sora in your states 0 net. So I want you to go to the green button, the alpha, as a second function. Have you seen that? So you press that alpha button, then ochaga button around the summation of x, and full stop up in blue. So the summation of x aripo pacalculator. That's that button in blue. But kuti tikwanise kushandisa those letters twakanyorwa in blue, tinotanga wapressa the alpha button. So wapressa alpha unopressa pane full stop. Just press alpha when up on full stop abo. What is it showing you on your calculator? Alpha unopress up on full stop. Yeah, but it's a summation of x, right? Yes. So you say alpha, then you end up on a summation of x. Yes. So what equals? So the summation of x, value, you have to achieve value of summation of x. 204.7. Yes, that's the sum of x. The n is also there on your calculator. N ukatarisa pana 0 apo, not again, not tangwa pressa on ngoti alpha, unopressa pana 0. You get the value of n. It's what? But the alpha unopressa pana 0 apo, what's the value of n? $20. So n you can even usinoshanda calculator. N is simply the total number of values you're given. So I'm going to add out my numbers or input mangani. So now let's calculate the mean. We have now the variables. The mean tabuti, the summation of x yatawana divided by m. So that's 204.7 divided by 20. So 204.7 divided by 20. So our mean becomes 10.235. To one decimal place, it becomes 10.2. So our mean is 10.2. Our mean is 10.2. Now let's move on to the variance, the sample, the estimate for the population variance. So the estimate of the population variance, let's go to our formulas. So for the variance, this is the formula. So S squared is the variance. Say 1 over n minus 1. Our n is not changing. Our n, we already have the variable n as 20. So our n remains 20. So our n remains 20. So already one of the variables tutorial kudara. Tava bana n, tawenda the other variable for formula yedu besides n. If you check tine summation of x squared. Take note, this is different from summation of x. Panega squared. You check for calculation, iripo summation of x squared. Per button runs plus or minus. So summation of x squared. Summation of x squared. So sum of x squared. Sum of x squared, you're saying alpha, then button runs plus or minus, what equals. What are you getting? $2,105.13 years. Then the last variable is sum of x in brackets. This is different again. Take note. What is the difference between the sum of x squared and sum of x in bracket squared? This means you are taking sum of x patabwana pekutanga pakutsvaga mean womusquare. So this is sum of x that is being squared. It's different from sum of x squared. Sum of x squared aripo pacalculator kadaro. But this one, it means you are taking sum of x, then you square sum of x. So sum of x tatamuwana patambo calculator. This is the sum of x we used, but a calculator mean 204.7. That's the one you're squaring. So sum of x bracket squared. You're taking that sum of x that we have that we use for calculating the mean, and we square it. So you're saying 204.7 204.7 squared. So it's 204.7 times 204.7. That's 204.7 squared. Now we have all the variables needed. It's now a matter of substituting them into the formula. Substituting the variables into the formula. So substituting these variables into the formula. So we are saying 1 over n minus 1, which is 1 over 20 minus 1, 1 over 19. So conserve bracket is 1 over 19. Then we open bracket. Sum of x squared to 1 as 2105.13. That's x squared minus. Inside the bracket, we have sum of x squared divided by n. So sum of x squared divided by n. So we are taking this sum of x squared divided by n. So let's first of all work it aside. Sum of x squared divided by n means we are taking this figure divided by 20, which is 2095.105. We then simplify that. And start by simplifying what's in the bracket. So that becomes 1 over 19 times, or you can just say that's 10.025 divided by 19. So that would be the variance. That would be our variance. That would be our variance. Now let's move on. So From there, the next thing that we need to talk about, or the question it said the population variance of the weight of all potatoes. Then question 2, a church organization has a total membership of 600. A survey conducted at the church so that 80 members out of the random sample of 200 had Bibles. Find the point estimate. Okay, so this one was just for the point estimate. Let's not waste time on this one. So this one, point estimate, you're just saying out of the 200, 80 has 80 out of a sample of 200, 80 have Bibles. So 80 over 200 gives us the percentage. I think it's almost the same with the one that we did. That would be 40%. Then you now say, so out of 600 people, what is the percentage? What is the number? You say the 40% of 600. It's the same question. They've just changed the figures, but it's the same with the one that we did earlier on. Now let's have the confidence intervals. Let's talk about the confidence intervals. The confidence intervals. The confidence interval. The confidence intervals. So if we are looking at the confidence intervals, the confidence intervals look at how confident are you. A confidence interval estimation is the range of values calculated from a sample data that is likely to contain the true parameter within a certain level of confidence. We are saying we are using a sample, yes. So the sample will not give us the actual data. It will give us an estimate. But how confident are we that out of the 10 people, taona isusu our mean, it is 42%. Taona average, it is 42%. The confidence interval says, okay, there can be room for error because tikanzi isusu calculate out of the sample at 10, tava taona paine 42. There is room for error, but we can give it a range to say, since from the sample, the mean mark is 42. There could be an error of maybe 5. So we are saying, of course, Chashansa sample. Tikaona kuti our mean mark is 42. There is room for error because this is a sample we used. But we can say, the researcher can say, I'm confident that kana pakanzipaitika error raitika is not more than 5. So we can say the confidence interval The confidence interval of the mean is, so tatisisu the mean mark is 42, but the researcher ari kuti kana ndatoita error inogona kunge iri plus or minus 5. So tinoita kuti 42 minus 5 and 42 plus 5. So tikati 42 minus 5 tobva taona inonzi the lower limit 37, and 32 plus 5, 42 plus 5, 47. So the confidence interval of the mean is saying, if we have made an error, the mean can be within the range 37 to 47. So tashandisa a sample and we got the mean as 42, but the mean could be between 37 and 47. Tikatonzi taita an error pakukcalculata patatanga kuti. So this shows us the range in which the mean could lie. This shows the range in which the mean could lie. If an error has been made. So tikanzi patashandisa sample taita error, the confidence interval says, okay, chero edu taita error, but the mean should lie within this range. They're saying even though there could be an error, the mean is between 37 and 47. The mean lies within that range. So the confidence interval depends on the degree of confidence, which is given in the question. The confidence interval depends on the degree of confidence. Which is given on the question. They will highlight the degree of confidence. They will highlight the degree of confidence. So when determining the confidence intervals, there are three cases. There are three cases when determining the confidence intervals. Case one, tinenge takaudzwa the population variance or standard deviation. So for the first case, the population variance or standard deviation will be given. So they'll say, find the confidence intervals, and will be given the population variance or standard deviation. So the population variance or standard deviation will be given. Population variance or standard deviation will be given. The population variance or standard deviation will be given. So the population variance or standard deviation will be given. The population variance or standard deviation will be given. Then let's move on. N or N, which is the sample size, can be small or large. So N can be small or large. For the first case, N can be small or large. Then we have case 2. There are 3 cases we'll be dealing with. So for case 2, the population variance will not be given. The population variance or standard deviation will not be given. The variance or standard deviation will not be given, and N will be large. If N is large, it's greater or equal to 30. N is large, that is greater or equal to 30. Then the last case we'll talk about is case 3. The last case is case 3. So for case 3, the variance or standard deviation is not given. Is not given. The variance or standard deviation is not given. The variance or standard deviation is not given. Then N is small. N is small. That is less than, our N is small. That is less than 30. So let's go to our document. So for confidence intervals, if you're determining the confidence intervals, determining the confidence intervals is based on whether the sample size, supposed to be the sample size, is large or small, the population standard deviation is known or not. There are 3 cases to consider. So for case 1, we said we use the first case. If N is large and the population is large or small, but the standard deviation is given. What's very important for case 1 is we know the standard deviation or the variance. For case 1, we are given the standard deviation or the variance of the population. We are given the standard deviation or the variance of the population. If we are given the standard deviation or the variance of the population, can you take down this? This is the formula that we use to find the confidence intervals. If we are given the variance or the standard deviation, that is the formula for the confidence intervals. So let's look at the question. Read through this question. An electrical firm supplies light bulbs that have a length life of approximately that is normally distributed with standard deviation of 20 hours. If a random sample of 40 bulbs have a life of 80 hours. Okay, let's do this one together. So you come across a question that's asking you for confidence intervals. Questioning and find the confidence intervals. The first thing to look for is, do we have the standard deviation, or are we given? The first thing to consider is, are we given the standard deviation or are we given the variance? They can give us the standard deviation or they can give us the variance. So looking at this question, an electrical firm supplies light bulbs that have a length approximately normally distributed with a standard deviation of 20 hours. So the standard deviation is given. So if the standard deviation is given, we are dealing with case one. So case one, yet tinotsvaga same confidence intervals. So if we have noted with this case one, the formula we are going to use is this one to get the confidence intervals. X bar, formula yedu X bar aningakamirira the mean. X bar aningakamirira the mean. This one akarapa kuka sigma, for that one yakamirira the variance. Akanakamirira the standard deviation, sorry. Akanakamirira the standard deviation. N is the sample size. Z alpha over 2, we are going to work it out together. I'll show you how we derive that. So let's go to our Excel. So example 1. So in our first example, the standard deviation is given. So looking at our cases, it's only the first case where we are given the standard deviation. But it's not given. So if the standard deviation is given, we use case 1. If the standard deviation is given, we use the first case. If the standard deviation is given, we use the first case. So if we are using case 1, so the standard deviation is given, so we use case 1. If we are using case 1, let's have the variables. So we need the mean, which is X bar. I can't put X bar there. Let's go to the question and find our mean. So the mean, which is X bar on the formula, we need our mean, which is the X bar. So we are told if a random sample of 40 bulbs have an average is the mean. So we took a sample, our n is 40, and our mean is 800. So our mean, we are told, is 800. What about our n? Our n is the sample that we took. Our n, we took a sample of 40 bulbs. Our n is 40 with a mean of 800. And our standard deviation said it was given, that's 20. So if we go to our formula, so far we have almost everything except one variable. So the x bar is the mean, we have it. The standard deviation, we have it. The n, we have it. But how do you get the z alpha over t? In order to get the z curve, or the z alpha over t, we use the normal distribution tables. We use the normal distribution tables. And the confidence level. And the confidence level. In order to get the z-curve, we use the normal distribution tables and the confidence level. And the confidence level. And the confidence level. So the first question is saying 95% confidence. 95% confidence. "95% confidence." That's question A. So 95% confidence using the first question. We are using the normal distribution tables and 95% confidence. So I want to show you, please pay attention to this part, how we derive this. So if it's 95% confidence, you first of all say 95%. Can I have 95 not 1 minus 95? 95% is 0.95. So you say 1 minus 0.95. That's 95%. You subtract the confidence level from 1 and divide that by 2. Subtract the confidence level from 1, you divide that by 2. So to get that z-curve, you subtract the confidence level from 1, you divide by 2. So if you say 1 minus 0.95, you get 0.05. You divide by 2, you get 0.025. So 1 minus 0.95 divided by 2, you get 0.025. You get 0.025. Zero point zero two five. You get 0.025. Okay, then let's go and substitute this into the formula. Oh, sorry, 0.025. We are not yet. So we've said in order to get the z-cow, we use the normal distribution tables and the confidence level. So we have used the confidence level 0.025. Now let's go to the normal distribution table and find 0.025. Let's go to the normal distribution tables and find 0.025. So this is your module. So there's this table. Let's find the normal distribution table. This is the normal distribution table. The normal curve. So under confidence intervals, you use this table in Pasaidaba. So Tutaga 0.025. Here is 0.025. So the answer that we want, the confidence interval for 0.025, we are using this. We are taking this 1.96. 1.96. So 1.96, that's what we are taking. That's the final Z curve. So it means Z curve is 0.025. The answer is 1.96. So I repeat the steps. So the first step, you first of all subtract the confidence interval from 1, the confidence level from 1, then you divide by 2. So it was 95%, divide that, subtract that from 1, you get 0.05, divide by 2, you get 0.025. Then you go to the normal distribution table. You find where 0.025 is. So from the normal distribution table, get that from the normal distribution table. From the normal distribution table. I'm all right. Ndiri pa office pangu pana Jason nani na angu pa next nebatane gardens. It's all right. Okay, so now we have all the variables we need. Let's now go to the formula. So the formula was saying the confidence interval if using case 1, we say mean, which is the mean with the 800 is the mean plus or minus. So the mean, then we have the plus or minus. So the mean, then plus or minus. So plus or minus, unfortunately, I can't put here. Let me see, do I? So with the plus or minus. So the 800 plus or minus. So after the plus or minus, Oh, is it giving me this? Okay, so the 800 plus or minus, then we say the z-cal we have calculated 1.96 times the standard deviation, which is 20, over the square root of n, which is the square root of n was 40 over the square root of 40. So the square root of 40, which is 6.32. 6.32. So what do? You split. So when you're now simplifying, you can first of all simplify with 800. You can simplify the 1.96 times so you can start by simplifying 1.96 times 20 divided by 6.32. 1.96 times 20 divided by 6.32. You get 6,202. 6,202. 203. 6,203. So you first simplify. After that, you split the confidence intervals or confidence limits, which atangana plus, sorry, which atangana minus, which ati 800 minus 6,203. So chatanga what 800 minus 6,203, one at the lower limit, which is 793.78. 0.7 or tongoti 0.8, 793.8. That is our lower limit. And our upper limit, we are adding 800 plus 6.203, which is 806.2. So these are called our interval limits. These are confident intervals. These are our confidence intervals. That's the first case where the standard deviation is given. And if the standard deviation is given, whether n is small or large, we use the first case. Okay, so do you have questions? Now let's move to the second case. So for the second case, there was another question, but this one you can try on your own. Let's move to the second case. So second case, the standard deviation is not given, but n is large. So our n is greater than 30. Our standard deviation is not given, but we have n greater than 30. We use the sample standard deviation. So if the standard deviation is not known, but n is greater than 30, we use the sample standard deviation. So if we are not given the standard deviation and n is large, we use the sample standard deviation. Let's look at case 2. The head of a rural primary school is worried by the big number of students who arrive late for school. In order to be able to adjust the school starting time, he sought to find the average distance walked by students to school from home. The mean and standard deviation of the distance traveled by a random sample of 60 students were 6 kilometers and 800 kilometers respectively. Construct a 90% confidence interval for the mean distance traveled by all students to school. The first question is, are we given the population standard deviation? So they have not given us the population standard deviation. The one that they gave us is the sample standard deviation. So unlike the first one had given us the standard deviation, not a sample standard deviation. So this one is giving us a sample standard deviation, the mean and standard deviation of the random sample. If you are given the mean and the standard deviation of a sample, it means we are using the second case. The first case, the standard deviation is a sample. So if you are given a sample, it means are equal. So for the second case, the standard deviation given is for a sample. This means that the population standard deviation is not given. But our sample size how many people are we dealing with is 60 students. So our sample size is greater than 30, which is large. Our sample size is large. That is greater than 30. Our sample size is large. That is greater than 30. Our sample size is large. That is greater than 30. We use case 2. We use case 2. We use case 2. So we use case 2. So for case 2, we use case 2. For case 2, we need the mean. We use the sample mean given. Let's go to the question and see what was the sample mean. So the sample mean, the mean and the standard deviation of the distance traveled by a random sample of 60 students were 6 kilometers and 800 respectively. So the mean is 6 kilometers. The mean and standard deviation of the distance traveled by a random sample of, so the mean is 6 kilometers. and the standard deviation is 800 meters. Take note, the other one is kilometers, the other one is meters. So we have to use the same units there. So the mean is 6 kilometers, which is in terms of meters, the mean is 6,000 meters. Then the standard deviation is 800 meters. So N number of students, or N, it was 60 students. The sample size is 60. Now we need the Z curve because the first one, the first case and case number 2, they're almost the same. They all use the Z curve. So the Z curve, I've said you first of all say 1 minus the level of confidence that we are looking for. So in this question, it's a 90% confidence interval. So you say 1 minus 90%, you divide by 2. 90% is 0.9. Divide by 2. So 1 minus 0.9, you get 0.1. Divide by 2, you get 0.05. So you go to the normal distribution tables. Unotsvaga 0.05. So Z cow 0.05. So our Z cow 0.05. Let's go to the tables. Our Z cow 0.05. Here is 0.05, page 2 up. So the answer that we want is 1.6449. 1.6449. So that's our Z cow. So our Z cow 1.6449. Let's go and substitute now that into the formula. Substituting that into our formula. The formula says X bar, which is the mean. So we start with our mean, which is 6,000 plus or minus 6,000 plus or minus 6,000. So 6,000 plus or minus the standard deviation 800 over square root of n, square root of 60, square root of n, that's square root of 60, which is 7.75. With 6,000, that's plus or minus So plus or minus, that's 800 divided by 7.75, which is 103.23. So we split that into two. The first one with plus. That's 6,000 plus 10.0, 6,000 plus, that becomes 6,103. Or the first one we start with subtractor, sorry. The lower limit we subtract 6,000 minus 103.23, get 5896.77. Then the upper limit you add. That's 6103.23. So that's case two. So that's our case two. So we can wait here. Let's have a short break before we get into financial accounting. So we'll start from this case. So next lesson, we'll start from case three.